your kind words on your perspective on the Polytechnic team. And Professor Vaidya also mentioned about the the product global and training for the students as well as the faculty. I think that is the one of the reason. I know when I talked to Dr. Suresh DS, we have been working for last 1 year or so. When I looked into their profile, it was a very, very humbled. And I think MLS have mentioned that it's in the remote. I never call it as a remote. It is one of the prime area. I don't see any difference between the remote and in the main place over there. So I'm very, very pleasure to work with him. And before I start a keynote, I would like to really express a thank you to Dr. Shanta and then Dr. Sridhar, who had really initiated this. And we started a discussion about 1 year back when we interacted with them for inaugurating the Center of Excellence and getting some of the components what we manufactured here and when extant solutions in Bangalore, right? So then we started collaborations, and it's very when it started looking into the memorandum of understanding, what 4 of the key areas we talked about. One was training the faculty, and the second one was the training the students, and the third one is how do we collaborate between the US universities and the India university, right? I've been working with some of the IITs and NIT. Already we had an MOU. For last 4 years, we have been working with the India team, and we had collaborations with NIT Agartala. But when Dr. Suresh approached us saying that, okay, we want to have some kind of an MOU and invite some faculty from CIT institute over here. So then I was jumped onto that opportunity and then introduced to some of the professor over here, and we signed up a memorandum of understanding. We want to have a kind of a joint collaborations for inviting the paper presentations, then collaborating some research projects. Due to this pandemic, all the plans have got pushed off. Otherwise, by this time, we would have had at least some researchers going on to this. So when when the programs are operated by here, so we have a great opportunity between the US government and the Indian government, right? So we collaborated with that, and we have certain grants and funds, which is unutilized. For last 2 years, I could not utilize that funds, So we have a lot of things to deliver here. And I'm pretty sure with the 6 days of course, I'll be talking about what exactly we are doing it, and my colleagues in Bangalore, they would be talking about how this blockchain and IoT. By the way, the topic selected by all the the selection committee as well as the AICT is a great topic. It's one of the upcoming topic from IoT to the blockchain, right? It covers up everything there. I will, within my allocated time of an hour or so, I'm going to cover up key aspects and the abstracts level on what the IoT and the blockchain, and provide some examples. And later, my colleagues probably in the next 4 days, they would be discussing a real and hands-on. Because all of our materials, mostly it's lecture followed by a lab. So we would be delivering those hands-on. Actually, our goal was to have a hands-on, come to the institutions, and our team will go there and train them. That was the whole point in the memorandum of understanding when we did it. But what happened is when this pandemic it happened, everything is happening on the online. Then we decided, okay, let's have an instructor-led course. My colleagues will talk about the instructor-led course where they'll have a kit along with them, and they'll demonstrate the blockchain applications, how we can use the blockchain for IoT applications. So without any further ado, it's my honor, duty to thank all the organizers, starting from Professor Chetan Balaji, then Professor Vijay D. Vaidya, who has inaugurated very nicely. He said that product, global ready, training, and IST, all the components, whatever is mentioned, we have covered up in the MOU, I guess. And then the Dr. Sridhar, we have been, like I said, working with him 1 year. When I looked into his work, I said, no, you are actually 2 or 3 steps above what we are doing it. I don't know whether you really need it, because we need to learn many things from you, Dr. Sridhar. We have got a lot of development already done it, but how we can recoup in the US, universities and the US technologies, that is where I think we joined hands. And then when Dr. Shantala, though I could not had an opportunity, I was just talking to her. before the inauguration. So I said I did not have a chance, but looking into the credentials, it's really great, eminent, personality you have, ma'am. So I think we're very fortunate that we have a collaboration with you. And last but not the least, Dr. Suresh, like he said, he's our good friend, mentor, and he has been giving us a lot of input, what is happening in the educational industry, IST. Whenever I call him, he said, no, I'm at this place, so it's traveling a lot in spite of this pandemic, So I'm very, very, very glad to know the progress, what he has been made for the IST. He was introduced through our common friend who is also in the Bay Area. So whose name is Mr. Bankar, who's the one who is interacted with us. And from that day onwards, I've seen the progress. It's a very, very hardening. And today I learned a lot of things. When during the inaugurations, Dr. Suresh never shared about all these things. I think that he has got lot many awards from Karnataka government, and Prime Minister himself had read the white paper, and then he has been eminent in this IST program. So I'm very, very glad to hear that. I noted down here. So I think whenever I share with my professors or my team, I'm definitely going to share with the permission of Dr. Suresh. So without further ado, let's get on to the topics. Again, like the introducer mentioned, my name is Shiva Kumar. In short, I'll go by Shiva. I'm based in California. So I'm affiliated with multiple universities, and I'm the CTO of Xtrans Solutions. We have two offices, one in Bangalore and one in San Jose, California. So, and also I would like to thank the MP sir, so who has actually given this opportunity to conduct this program. So Dr. G.S. Basura, Chairman, CRID Society, and then the Mr. Let me GB Ganesh, who has actually said that, like, it was a remote, but no more a remote. I'm just correcting it, not a no more a remote. It's a main same city. So thank you all for inviting me. It's already getting late. Let's get on to the program here. So I want to share my screen here, please. Can I share my screen, sir? Dr. Anil Kumar?
Sure, sir.
हाँ आ गया 2 मिनट.
Is my screen visible, sir?
Yes, sir.
Okay, all right. Okay, so yeah, today's topic, is the blockchain and IoT, right? Let me start with an overview of blockchain. Sir, please do let me know when, 2 minutes before, so that, it's 9:30, maybe I have time till 10:30, if I understand, 10:30 of California time here. So now let me start with a blockchain history, I think I was just going through just a very quick audience list. We have mix of engineers, right? I think few are from the business oriented, and we have electronics and communications, then computer science, instrumentations, and others. I guess normally I take the statistics, before I start the any convention or any keynote. But today, because of the time, I'm assuming that a majority are from E&C, computer science, or engineering. But nevertheless, the topic what I'm going to cover up, it actually touches everyone's offerings and everyone's day-to-day activities though. So we have the let's start with the blockchain one, which is basically currency. I mean, everyone, all of us, that Bitcoin, when it started, we started with the blockchain. The founder said that the finance department need to have a secured technologies. That's where they got it into the blockchain, into the finance, and slowly everybody learned that the success of blockchain one currency into the. Then they said, okay, let's have a smart contracts in the blockchain too. They said, okay, now we had a currency for a blockchain, let's have a smart contracts, right? Then they started putting under smart contracts. And then in blockchain version 3, we have decentralized applications, right? We basically, when I say decentralized applications, I always give this example, we have, the railway reservations, right? There's a typical example, right? We have a railway reservations. We have a central control with all the terminals, they operate it here. That is basically centralized, right? Whereas in the blockchain, it is a decentralized, right? Which means that it's just not the central computers where it's based at Delhi, Mumbai, or Bangalore, the major cities. So it is also connected to the terminal, right? The terminal also, or the individual operators also, will have some kind of an control on flow of the data, right? Flow of the data, flow of the message, right? That's we call it the decentralized, right? Just imagine that going back to the earlier technologies, right? We have centralized, now we are going to decentralize it. Everyone have some kind of a control over that. And then slowly everyone thought that, oh, wow, this is getting really interesting. Let me go to the industry, right? They said, okay, all the industry consortium, industry standards, they all thought that, okay, now we will, have this success onto the industry. Then industry, we have an industrial IoT, I talk about that. And then we have an Internet of Things itself and various enterprise organizations. They all thought, okay, let's go to the, let's take the blockchain into our applications, and they started implementing onto that. So this is the actually some kind of a generation of a blockchain from 1.0 to 4.0. Now, the evolution of blockchain. Okay, this is again if you go into the deep dive into the technology, we have 2008 to 2018. We have a blockchain 1.0, simple and a single parameter. So when you had 1.0, we had a very single parameters. That means when you have a Bitcoin operations, it's a very single operation, single parameters. Okay, we have the target was the finance. Okay, we will maintain a single parameter database that record the transactions, right? It's whatever the currency you have a dollar, or you have rupees, or you have a euro. So you want transactions, and you slowly migrate it into the multiple parameters. That is very focus was on single parameters. And then in the blockchain too, we actually started implementing the business logic there, right? I mean, I'll come back to that, why the blockchain itself is required. But let me go through the history on that. So we have a blockchain logic, and then legal clauses, then corporate governance in the smart contract. So basically, business logic is whatever you think of business. For example, we all buy the product, right? Online, we have an Amazon, or you have local any buying companies. You buy it online. So now, when you buy it, any product online, there is a logic behind to that, right? You have a desktop, and then you have a a connections. It could be a networking equipment. From networking equipment, then it goes to the internet. From internet, it goes to the central server there, right? So we have business logic to that. Okay, fine. Business logic works is that. But how do we implement a secured transactions from a consumer point of it to the server, right? So that's where the blockchain will come in picture, right? Then two, they started thinking about the business logic. Government also realized that it's a good techniques. Let's start implementing on that. Then corporate governance implemented. And then in blockchain 3, end-to-end blockchain here. So initially in 1 and 2, it was just okay, a portion of it, right? It is, though its name was the blockchain, because it is a everyone has to agree in the community or in the whole chain, right? If you want to implement a blockchain, for example, take the railway reservation only. I'm just giving an example. Now, if you want to convert that centralized reservation system to decentralized reservation systems, that means we need to convince all the stakeholders, stakeholders from the centralized, then stakeholders on the desktop versions, stakeholders on the all the operators who are operating. It's in one way I'm converting all the terminal into some kind of an intelligent systems, right? Because terminal is not an intelligent system. You're just feeding the data, right? You're just putting it here. Okay, somebody come for the reservations online or go to the counter. You just enter the detail, and then terminal will just enter the detail. The processing is happening in the back end in the some computers, right? It's sitting somewhere in Delhi or somewhere in some place there, right? Of course, they have a redundant pieces involved everywhere. It's connected there, right? So now terminal are becoming an intelligent now. That means you need to have a CPU. You need to have some kind of processing algorithms to process it in a secured way. That started in blockchain 3, end-to-end blockchain, and then the business architectures, then stable coin and tokens. And now today we are into the blockchain 4. Era, which is basically interoperability, right? Now, because you see, when we had a blockchain 1, maybe, we had only one operating systems or two operating systems, right? For example, you have in Windows, then, the Mac, right? Now, when it comes to the another operating system, say, for example, Linux, so it has got his own versions or it has got its own samples, right? So we need to address interoperability. So whenever the word I say interoperability, it should work in all the operating systems or it should work on all the platform. It could be in hardware, it could be your software operating systems, or it could be on the applications level, right? So then seamlessly value exchange, we need to exchange it, right? We don't have to wait for that machine to decide oh, this operating system it doesn't work, this operating system it doesn't work. Then it's not a community or a blockchain, right? Whenever you're saying a community oriented or a blockchain, so you need to make sure that it works in all the platform, right? So that's the 4.0 people they started thinking about that. And machine readable, then complex operations. So we'll come about what those complex operations with some examples of them. Now, what are the basic components or the features of blockchain? It's basically 4 things you must remember. You will be hearing a lot in next 6 days, from my colleagues, as well as I was also going through all the eminent speakers there, right? So they're all come from a very fantastic background, so you will be definitely hearing in detail about these 4 components. It cannot be corrupted. So any data you give, it cannot be corrupted. It has to be same. For example, I have 5 members in my team, one in California, one in Bangalore, one in Hyderabad, one in Mumbai, and one in in Europe. So if I have got a 5 parameters, if I initiated some transaction, that transaction has to remain same there. I'll come back on what is a transaction when I discuss about the use cases. It cannot be corrupted, and it has to be decentralized technologies. So decentralized technologies is, again, I go back to that railway reservations, right? No more that you process it at a center, right? I'll be processing my own data and send my encrypted data to the next block or next city, right? That is a decentralized technologies. And enhanced security. Of course, the whole purpose of the blockchain is the enhanced security. And we have a distributed ledgers. So distributed ledgers is nothing but it's actually, go back to the English word itself, right? It's a distributed ledgers. I have a ledger, I make my point here, and then I submit it to my Bangalore team or Europe team. Then that ledger is marked over there, right? So it's I'm distributing it. So these are the 4 basic pillar of a blockchain, how the blockchain it works there. Now let's apply in our real life and real applications over here. So this is my favorite slide. Always I show it, come what not, whether it is an IoT conference or blockchain or artificial intelligence, right? So this is how we grow, right? I mean, I have been watching the technologies, right? So on the bottom layer, it's an internet of thing, right? We have a connected devices. We have, several applications on that, right? So we have environmental, then agriculture, water, so name it anything. And the bottom layer is your IoT or connected devices, right? And then all the devices data is coming to the cloud now, right? So we have a cloud, you name it, whether you have a enterprise cloud. I'm sure most of you are coming from the university or a polytechnic background, you have some sort of a cloud here, right? So when you connect to this cloud, You get all the data to the cloud, and then you have various data, right? It could be an AWS, it could be IBM cloud, or it could be MATLAB has got its own cloud, ThinkSpeak. I'll be talking about that. And there's so many are there. At least there are hundreds of cloud companies, right? So data is coming to the cloud, and then when it comes to the data cloud, we have a data analytics, right? Now we become really hungry, right? When the data is there, and now I need to analyze that data. How I'm going to analyze that data, because there are tons of data is coming from all these devices, and then I got a data analytics. So when I have the analytics, I have a machine learning. I want machine to decide for me what function I am going to run that. And then we have artificial intelligence. Once I have the machine learning algorithms, it's tremendously is going there. I teach, in fact, one of the subject, my favorite was the data analytics and foundation course on artificial intelligence. So I've seen that every semester, every quarter, when I go through all the course material, I'm also learning, by the way, because it's every time, every quarter I see there are new algorithms are coming up, new mathematical solutions are coming up. I'm trying to implement it, and then learn myself before I really myself be ready with the teach, right? So machine learning is there. Artificial intelligence, of course, lot of input coming from the machine learning, and AI is cutting edge technologies. I know initially Dr. Shantala mentioned edge devices, right? You heard about that in the initial inauguration. Edge devices, yes, edge artificial intelligence is happening on the edge devices. One example I'll take is that recently we are working with an NVIDIA. They have a strong CPU and strong GPU technologies. So we solved, in fact, in last semester, few of my students, they delivered some of the project presentations. They solved some artificial intelligence on edge devices. What is edge devices? Very nicely said by the eminent speakers earlier. They said, okay, edge devices are there, and it has to be product ready, right? So they're a product ready. So now once you have that artificial intelligence, then it's a robotic, right? Now robot has to operate for some of the functions, like your manufacturing, your day-to-day operations, everything has to operate on that. So now, of course, always it comes to mind, right? When I say it's not only in over there, here also, I see that it's kind of a age demographics, right? When I ask the students or a faculty in the range of 20 to 30, they all appreciate, okay, robotics is a good one. Okay, robot is doing it for me. I just need to have this one. But when I ask the demographics at the age of 30 to 40, they're still okay. They said, okay, I learned a lot in the in the hardware, in the operating systems, firmware, and the middleware. Now I had to learn new technologies, especially Python programming. A lot of algorithms have to credit, and artificial intelligence, as you know, is a mixture of everything, right? It's just not the programming, right? It is a statisticals. Then you have got a probability theory. Everything is involved in AI, right? So they are okay there. But when I ask, in the range of 40 to 50, 40 above, they say, oh, robot is coming up. Will that my job is there? Our robot is going to take. So to my perspective, even I'm also in that range. My perspective is that it's not taking away in that any job there, because the only thing is we need a lot of developers, lot of engineers, lot of faculty and students who are skill trained on these technologies, right? We need to get trained on these technologies. That's one of the initiative why we are having with Dr. Suresh when he signed up in MOU, right? How we can implement on this. So, and then of course the sky is the limit, and you need to keep learning on all these technologies over there. Now the blockchain, where the blockchain, you must be wondering that why we are showing this diagram in the blockchain, right? Now blockchain comes in all the field here. You see in the bottom layer, you have got the IoT devices and the cloud devices, data analytics, machine learning, artificial, and robotics. So the blockchain sits everywhere here. Actually, we didn't show the block here, the blockchain, but I'm going to show one more slide where it shows you how the blockchain goes into an individual connected devices over there. Okay, so what are the components? Now let's go on to deep dive into the blockchain components, right? What components we have? We talked about what the blockchain itself, decentralized, it has got a ledger, and it has got secured connectivity with all the components of the block, right? So let's see what are the components. We have a node. So when I say I'm going for the top here, we have a node is a user or a computer, right? Like a terminal or a central computer, because in blockchain all computers are same. Everybody, all the systems, all the devices. When I say devices, the computers, or it could be mobile, or it could be your laptop, or it could be your what you call that, handheld devices, right? So when I say node, all the node has got a computer with the blockchain. Transaction, smallest building block at a blockchain system. This is a transaction. Each transaction has been metered, and there is a block. Block is nothing but a data structure used for keeping a set of transactions, which is distributed to all nodes. And then we have a chain, a sequence of blocks in a specific order. And then we have a miners, specific nodes which perform the block verification process. So this is a very intensive process in the miners. Whenever I say miners, then specific nodes which perform the block. So basically, everybody cannot become miner, right? They will say that, no, I'll become a miner. No, you can become a miner, but you need to have a heavy processing engine there, which cannot do by this laptop or cannot do by the server, right? So they have a really very heavy mathematical operations engine over there. And then consensus. So we need to have consensus for everybody. Each transaction, it could be anything. You're changing from 1 to 0, 0 to 1 in a 64-bit extended architecture. I'm just telling you, if you see the 64-bit extended architecture computer, if you take, you will make billions of operations there, right? If you take an IPv6 today, you can make a billions and billions of transactions on the network, right? So now in that case, we need to take consensus from all the stakeholders in that. That is called a consensus. We'll see what consensus we have to take in the individual block with it. Okay, this is a little bit of giggy or a technical here. So we have, blockchain, how the working principle it works. So block 0, block 1 is nothing but a different computers. We have block 0, block 1, block 2, and then it goes up to block n, right? So it works on two concepts. One is the hash, and another one is the reference hash or a previous hash here, right? So whenever I have the block 0, when I send a transactions, for example, I'm booking some item on the computers, right? I just say that, okay, now I want to buy a phone here, right? Just say iPhone 13 or smartphone, whatever, I want to buy it. So whenever I make a transactions, then it create some kind of an hash, and then it goes to the networking. And then networking also, it says that, okay, this particular one is created over here. So now this hash, you go to the block 1. So block 1 could be anything. It could be your networking equipment, or it could be next to something processing equipment, or it could be central server. I mean, it could be some other server, actually. Everybody's server here we talked about. So now this one EB1, this go to the block 1 here. And then, there is this block generate another hash here. This hash will be input to this block 2, like that, it's so on, it goes. So just imagine that what is happening here is, what we are doing here, eventually, if you see the, in the binary logic, just say binary logic. So when I have the binary number like this in my transaction, this is my block 0. I'm taking this block 0 and taking it to the block 1. So what is happening here? I got say it is a 4 byte of information. I'm just giving a 4-bit. Let's take a 4-bit, 1EB1. Just say simplicity. We see is a 4-bit of information. That 4-bit of information is coming to next one, and then this one. The checksum, what we call the checksum of 2DC1, 1EB1, it has to be unique number, right? It cannot change here, right? If you change anything in this transaction, then obviously the checksum of this block one will change, and immediately it raises a flag, right? Oh yes, somebody has changed something. Now it cannot be do. Now we have to go back and ask this permission from block 0 right here. So similarly, block 1 here, 1EB1, it will be an input, 2DC1 will be an input to the block 2, and then we have a 3EF3 is the next one generated. So checksum of this will be maintained here. So like that, it keeps on going there. So what we are doing is, we are generating some encrypted or crypto informations, feeding it to the next block. Next block will process that information, and then next block will submit to next block there. So like that, we do that. So basically, any change of data in one block changes the whole hash program and not invalid data for the subsequent blocks, right? So it's, I don't know at least when we started, I think few of my senior colleagues are also here, or you know that we have a peer-to-peer. No, when we started a computer, it used to be peer-to-peer, right? So it has to. I need to connect in a circular way. I connect one terminal, connect to next one, next one, next one, next one, peer-to-peer, right? And then come as a centralized one, right? So we have a centralized one, then you distributed one this thing. So it's like a peer-to-peer network. Everyone has access to the block data, and smart contracts, what we call is nothing but a program here. So these are the different types of blockchain types, permission point of view. We have a public, private, consortium. So basically, it all structured based on how you design it, right? If I have a private, then I have only enterprise. Like for example, this CIT could be institute. They want to have a private networking, and we'll have a private contract, right? So only all the faculty, HODs, and president, everyone will have some kind of an network, and everyone will generate that kind of a blockchain token and use it. And then public, it will be public, but public means it doesn't mean that it's like open source, right? Everybody has to contribute to that here. And then consortium, basically some of this, the open standard committee, they have this blockchain committee. And when it comes to database, we already talked about centralized and the decentralized over here, right? Okay, so let's talk connect to some IoT devices, right? Since the topic is on Internet of Thing and the blockchain, I took this opportunity to bring my research area, what we have been doing it in California in multiple universities. So I thought, let me share some of our research, what's going on the IoT and the blockchain. So we started with the IoT, then with the artificial intelligence, then with the machine learning, artificial intelligence. Now we are entering into a blockchain, right? With all the data is given. So whenever you ask anybody, the IoT. So in university, the standard dialogue is that no, we have IoT. IoT is already over now because these connected devices. Because we have been connecting devices, we have billions of devices, trillions of data is coming up now. How we are going to make it securely, right? That's talk going on, right? That's why I was very impressed, when the organizer said that they're going to have this blockchain and an IoT. So that was very near and dear to my research, what we have been doing it here. So this is Internet of Things. Devices are going here, 50 billion devices. We have a data structure, and then transaction record secured way. So that's the one, right? So we have a data. Data was there even when you have an Internet of Thing and artificial intelligence or the machine learning, right? But in a transparent and a decentralized way is the what we are now looking into the blockchain here, in the blockchain and the IoT systems over there. So now what is motivating us? Okay, we are all innovating, like Professor Vaidya mentioned in the inaugural talk. Okay, we'll have to be, that's great. Definitely we need to have an innovative. But I just complimenting Dr. Vaidya's statement, why we need to have this kind of a thing, and what is motivating us. See, this is a statistic I've taken, global internet user growth, right? So it's again data is about 6 months old data. Now I could not get time to get my new data. So what they're saying is that nearly 2/3 of the global population will have internet access by 2023. So that's very true. In fact, I would say it's excel this data also, right? I mean, take for example in India itself, right? So the mobile phone, right? If you really see the 5G now is coming up, or it could be a simple Ethernet connections, right? So or Bluetooth connection. So when I say that, you see that in India itself, the number of devices is equal to total population of US. That was 1 year back, about 360 million or so, right? Number of devices we have 360 million. I'm pretty sure it has 1.5 times more, right? So whenever we discuss about any strategy or anything, in our company, I said that first we need to focus, or we need to take care of those emerging countries, right? Because the market is over there, right? We may be having the innovation research over in US, but where is the market? Market is definitely in India or China or some other place, right? Where the people are consuming there, right? I will come back to another data set, about the data itself, how many people are using the data. So this is our motivation. And devices and connection, number of devices connected in IP networks, is more than 3 times the global populations. That's very true, right? I mean, So now so many devices are getting connected to the internet. Now, how secure is the data, right? I mean, today, people, okay, fine, we can put the data on the Facebook or we can put up data on the WhatsApp, but how safe is that? We keep hearing that, right? I mean, sometimes we keep hearing all of a sudden, no, what, don't click on that. WhatsApp, whenever you click on that, the phone, all the data is taken it out. I'm not an expert on that, hacking the data and all, but it's a scary, right? So if you don't have this kind of a, technology and the solutions, so this is another motivation factor for us. And then another one is that this is from the IBM, what the IoT in the blockchain. IBM, by the way, they are very strong, going very strong in the blockchain for IoT devices. I was in another conference, sharing the one of the panel. There was an IBM, top executive came there. We had a very interesting discussion there. In fact, I taken one of the slide from them only. So they said that it is a Internet of Thing enables such devices to send data to private blockchain ledgers for inclusion in the shared transactions, right? So all the business partners can verify each transactions, right? So they are the whole point of putting this one is that IBM is very strongly behind into this blockchain technologies. In fact, they have got already 2-3 major applications they have done with major grocery segmentations. I know food segment, they have implemented one of the technologies which I don't have time, but definitely I'll be happy to share some of the white paper what we worked with the IBM team over there. Okay, so let's see what's the data set, right? We have an internet, companies like IBM is supporting. Now, what is the data set? Again, this data is not a current one. This data is little bit of outdated, but still, it's fairly new. I would say 3.5 billion people are on this thing. 68% are the Facebook user, and average time they spend is about 3 hours daily on social media and messages, and 54% users are for research products. Yeah, this is one very important. 54% they use this data, whatever you buy anything, like anything, dislike anything, put it on the Facebook, put it on the WhatsApp, put it on any social media. So it's basically they do it, 54% use it for research products, and social media impact is about 71 products, 71% they build a product based on this, right? The data, whatever. And 91% are the mobile users, like I was saying that, right? Whole India populations is, whole India, the mobile users is equivalent to US populations, right? So you can imagine that. So these are the motivation factor for technology innovator to come out with some sort of an secured system, so that all the we enable the community and keep innovations growing there, right? Now let's get on to some technology implementation here. Okay, so why blockchain in IoT applications? Blockchain are in many aspects, right? Started with the blockchain version 1 we talked about, right? We have the what you call the finance sector, but then we moved on to the business logistics, and then we moved on to more of an it's enterprise, and then now we are everywhere, right? IoT. So I've taken this one challenges. Here you see there are 4 the block diagram, right? I mean, that I mean, those who have done an IoT or a simple Internet of Things diagram is that a sensor, then we have a processors, and then gateways, and then the applications over here, right? So we have a sensors. It could be any sensor, right? It could be temperature sensor, humidity sensor. You take it anything. In fact, mobile device is also a sensor, right? I'm sure most of you know that any smartphone, if you take, they have at least 15 plus sensors into that, right? I'm just saying the new smartphone, if you take, they have multiple sensors installed in the phone, right? That's also a device. And then we have a processors here. In IoT, we don't need a heavy engine CPU, right? It's just a microcontroller will do, right? Because the data is coming in 2-line or a 4-line. So we have a processor, and then the gateways, right? It could be your Wi-Fi gateway, or it could be cellular gateway, right? Network connections, and then we have applications, right? So here we used to send the data secured sockets layer, right? We used to call it as SSL. I don't know if you're familiar with the secured. So we had a secured sockets layer here, data, right? So now, is it good for when the devices are going? You remember we talked about the 50 billion devices in 2023, right? Today we are talking about the 25 billions. It's actually surpassed the most analytics, they say that it's going to be 20 billions by 2020. It's surpassed, real fact in that. So growing with respect, can SSL handle? SSL cannot handle secured it cannot handle, because there are so many devices are coming up, very tiny transactions are happening up. How long you can maintain, and then you are really loading the microcontroller, because microcontroller is just taking the input and then sending it there. So if you take the Moore's law, I know most of you know the Moore's law. In the Moore's law, what Moore's that Intel main founding father of the Intel, right? Moore's law. So always used to say that, right? Every 18 months, number of transistors are going to be double, right? So when you have a single bit, 4-bit, 8-bit, 16-bit, 64, 32-bit, 64-bit, right? So every 18 months, number of transistors in that chip is going to be double. It happened right now, but now are we going to okay, most lies is there, but now for last 1-2 years there is some contradictory is coming up. Now whether the most is still holding it, because now connectivity has come, centralized operation is come, so whether it's Moore's law is coming up there, that's a different discussions. But still it is holding. Majority of the devices is holding the Moore's law, right? If you take any Intel processor or EMD processor, any other processor, the number of transistors or logic gates inside are doubling every 18 months. And that's true, almost holding it. Now, but with having this one, is the security layer is good enough? No, we cannot, because so much of devices, billions of device transistors inside. Now, can we make a secured SoCs or secured chip to that? It's impossible there, right? So that's why we have to have some kind of a technology. Of course, one can invest on. You can invest on embedded encryption. Okay, somebody asked me. I'm also from a hardware background, basically. So somebody asked me, because I worked on the hardware design, hands-on hardware design. Somebody asked me that why don't we have an encryption? We can have an encrypted one in the chip level itself, and then get onto the this one. We can have an encryption operations and then fuse it or burn it within the chip. We can do that, but it's very expensive, right? Very expensive. Second one is that if you want to make any changes, then again you have to change that chip itself, right? You can have an encryption. Okay, now I'm locking this device, locking this transaction for this particular, my temperature sensor, for example. I'm reading it. It has to read the temperature. If anything going beyond that, then my encryption circuits should not work there. Okay, I can do that. But how many do that? Suppose if I want to change tomorrow, I'm just giving an example. I want to use the same port or the same pin in a CPU. Again, I'm talking about a little bit on the electronic side. If you have the same CPU pin, then it's difficult to change it, right? You need to send back to the foundry, hey, I've connected that time my temperature. Now I want to connect a humidity sensor, right? So that's not practical, right? Software can be changed anytime, right? I mean, when you see software, for example, when modem came in software, most of us, we didn't like it. Oh yeah, software can do a modem modulation, demodulation for any sending that, right? We didn't like it. I mean, most of the hardware engineers, but it's true today. It's modem is everything is a software built in, right? So like that, so it's very costly. So that's why we cannot handle this kind of an a Moore's law when you have a secured socket layer here, right? So this is again my favorite hands-on diagram. I'm showing it here. So take that example of the secured layer here, right? The IoT device. So these are the components here, right? You have I just shown an open source hardware here. Those who are familiar with that, this is a Raspberry Pi. Is a microcontroller there, and then it has got the input port like I2C, UART, and SPI interfaces there. All the sensors are connected here, and then those sensors, what I'll do, I'll send it to a cloud, which is an MQTT, is another IoT protocol. You can send it to HTTP, simple HTTP, you can send it, but MQTT is the protocol here, right? So I'm just sending this data, the simple data I'm sending it. Okay, now fine. What I can do, how securely I can do it, I can say example, I'm using my Python programming. Temperature sensor is an I2C. I'm doing this temperature and then connecting to the cloud, and then then cloud will have some kind of keys. They give me the keys, and then that keys I will embed within my Python code here and make it secure. That's fairly good. If you integrate a ThinkSpeak, you just get the secured code here, or API we call that API. You include it in your code itself here, software code or Python code here, and then you make it a secure here. But it's still breakable. Anyone can get into the Raspberry Pi. They can still break it onto that. So let's see how we can implement a blockchain so that nobody cannot touch that your code, or corrupt the data, or corrupt the message over there, right? Yeah. So this is another schematic diagram which we have implemented here. In fact, that CIT Goodby has got a similar tool from the Expand solution, the similar IoT boxes. When we signed this MOU, so they have these IoT boxes for development of the applications for IoT, machine learning, artificial intelligence, and the blockchain here. So this is all the sensors are here, and we have we program it using the Python and upload the data here, and then now we have an user 1, user 2, user 3. So in a simple IoT without blockchain, what we do, we basically we just send the data here. Okay, now I got the temperature sensor, gas sensor, light sensor, soil moisture. I send the data through my Raspberry Pi and then send it here. But in blockchain, I need to have some kind of a specialized or a customized software within this. It's nothing but there is a server sitting there, server and a client, right? There is a server and client component sitting into this box, and that server has got some kind of a flavor which goes into all these user. Okay, now this user 1 has got some flavor of this server, some user 2 has got some flavor of this server, user 2 also has got some kind of a user flavor. Sorry, it should have been user 3 here, user 1, user 2, and user 3. So all these users will have some flavor in this server model. So anything you do, that server would be a strong gateway. You connect it only through that server, Whereas in a non-blockchain operation, what we do, we just connect it without any server here, and just send it here, right? So here, a server is a kind of a gatekeeper. That gatekeeper will maintain all the transaction over here, right? Yeah, right. So this is my actually I'll take the questions. I'll keep some, definitely I promise that keep some time on the questions. I also want to check the timing with the organizer here. Let me just complete it here. So this is a blockchain implementations we have done, which my colleagues will be showing the demo. We have this is a platform we build it here. There's a Arduino board and there is a Raspberry Pi board. You connect your Ethereum. There is one of the blockchain technologies which you will be learning it in the next 2 to 3 days. So that we are implemented here. This is nothing but a server, and then we have a Linux OS because it works very good at the Linux Ubuntu. We installed the Linux Ubuntu and installed the blockchain, and all the sensor what mentioned here, right? Gas sensor, soil moisture, Bluetooth. All these sensor components are installed onto this, and then it's securely connected through an Wi-Fi here. There's a Wi-Fi network here through the server. The server means it could be any IoT server, it could be AWS, or it could be your IBM Bluemix, or it could be simple ThinkSpeak, right? So we connect all these devices, and this is the process involved here, steps involved. We will go through that. If anybody is interested to get your blockchain implemented on an IoT device, do let us know. So we'll be happy to help you out. We need to have a good microcontroller. Raspberry Pi 4 is good. Actually, we can implement it as open source because we're all from faculty and background, right? So we get an open source platform only. We cannot get. Of course, now we have a NVIDIA. They are more onto edge computing or more into robotics, right? So we never tried the blockchain onto that. So this is the implementation over here. Now let's go to some very quickly on the use cases here, right? What are the use cases? How I can take this onto a real implementation class. So hope you are getting it right. So we have 4 components in the blockchain. You take the blockchain into an IoT devices here, and now let's see some use cases. Where we are using it here, where we have already implemented some of them here. One of the recent research which we have been doing. The learning, research, right? It has to be useful to the community, right? I know earlier speakers talk about that, right? It has to be innovations, it has to be community oriented, and you need to, as a student or as a faculty, you need to be product to the companies, right? So this is the COVID vaccine supply chain. I have taken it from the World Economic Forum. This is the diagram. This is the reference from the World Economic Forum. They said blockchain is going to play an important role here, right? So we have COVID vaccine supply chain here, and then all the supply chain coming from the industry. Then you have got the manufacturing, the logistic itself who carries that, right? FedEx or your DHL, they carry that vaccination, right? And the clinic also, right? So this is a chain, right? Just imagine that we have three blocks, right? First block is the manufacturing track shipment. Now second block is the shipment, right? We're taking the shipment here. And the third one is the hospitals and the clinics, right? We manage that one. And fourth one is the people like us, individuals, we're getting the vaccinations or the booster vaccinations, right? So these are the four blocks are there. Just imagine that this one block, second block distributors, third block is the hospitals, and the fourth block is individuals. Now how we are going to maintain the vaccination, what is coming up, right? And how you have to make sure that all the qualities, quantities, it's coming as per the, we call it the CDC guidelines, right? So CDC guidelines. So now blockchain is helping to keep monitoring, and we call it the ledger system, right? We talked about the ledger system, right? So we have a ledger which each system is happening, right? I mean, we keep reading that, right? Sometimes it used to happen. Now the vaccination is good supply. I think I'm assuming that there's no manipulation is happening, right? Because it happened earlier, right? I keep reading. Initially, when they released, okay, only this segment, government said that, okay, only this segment will get it, right? Essential staff, doctors, nurses, and then who are all going every day, breadwinner, right? They get the vaccinations. So then in between, I heard that there was some malpractice happened. So this system definitely protected malpractice, right? You know that each individual vaccine, when you supply from the manufacturing to the distributions, logistics, and then the hospitals and the user, you know that you can really keep a track of each vaccine, where exactly is going that path, right? That's the World Economic Forum has said that blockchain can monitor the COVID vaccine supply chain, right? Yeah. So these are more diagrams are there. I mean, I will come back on this. This is a specification from the CDC guidelines. So it's Moderna COVID-19. They have certain guidelines, So I will come back if time permits. They have given the guidelines. Okay, it has to be this temperature, because we also should make sure that when you supply the vaccine from the manufacturing to the clinic and to the end user, it has to maintain certain temperature, right? You know that the major the requirement in COVID is that you need to maintain that minus 25 to minus 15. It depends upon the manufacturers, right? It will be in the minus 25 to minus 50 range, right? So you need to maintain that. Then blockchain can help us to see whether record in the ledger, right? Whether they're maintaining the temperature, right? And then the next one is the agri-food supply chain management, right? So you have, like I mentioned, IBM, they tried, in one of the agriculture food supply chain for the Walmart. Basically, the food was coming from China, and then they supplied to Walmart in central locations in, Arkansas State. Arkansas State is the one where Walmart is headquarters. So they maintain that, starting from, say, for example, food processing, right? You get the food processing and then get from that, and then it gives it to the customs. When it comes to the customs, the China customs. When it comes to the US customs, then US customs to the the Arkansas state, the Walmart headquarters, right? Walmart is a big giant over here. It comes there. Now IBM has implemented a blockchain to see that the same product, the food processing, what is processed in China, in Shanghai or whatever city, is having the same similar quality. When it comes, there is no manipulated, right? There's nothing is added to that, So they have added certain blockchain keys to that food mark. When it comes to the customs, they say that, okay, customs will see that, okay, this is the same product. When it comes to the US customs, okay, the same product. When it comes to the inspection in the Walmart, the same product. So the input, production, processing, distribution, marketing, and the consumer. So when you market it, again, when it comes to Arkansas, they got thousands of Walmart store, right? So it goes to Walmart store, and everyone will make sure that they have that token or the blockchain code then blockchain code, make sure that you get, and then the consumers. Of course, sometimes we have a consumer code. We just have to say that okay, it's a blockchain compliant. It's coming up from this and city, so they can get it certified from the US government or there. So this is another one, smart environmental monitoring. This is again a part of the when they introduce my bio, they said that I'm part of NIST, which is the National Institute of Standard Technologies, which is based in Maryland. They are the government body, so they are a Department of Commerce. So they provided us some grant to develop some project here. We developed a smart environment monitoring, right? So we have what it does is it actually monitors the air quality, temperature, gas, and the light sensor of a city called Ronald Park, which is I'm associated with the state Sonoma State University. So city of Ronald Park said, okay, we want to monitor all these parameters through your IoT initiative, and it comes to IoT cloud, and then it comes to the your smartphone, then desktop, and your gear, right? It could be an Apple Watch, or it could be your any smartwatch here, right? So you get all these components here. Now we have implemented a simple IoT. Now the last year we have developed the blockchain, but we could not demonstrate at the NIST. In NIST, normally they have one conference every year. Normally it will have in the February in Washington DC, where the DC, in fact from Capitol Hill also, Secretary of Commerce, everybody will come there to see the demonstration there. So it's happening for last 3 years, but last 5 years. But last year we did not happen. Before that there was like some government shutdown, so we did not have it. So last 2 years we had, but this year they're planning to have an online. So we are going to again renovate this. So this is the program. If any researcher, any innovators, if interested to work with the NIST, please go to the Smart City program of NIST. They would be able to guide through the process involved. So this is the project, the city. For the city we did it, and it's a very simple project, again using open source ground, and then it's a complete block is the chain has been maintained over there. This is another project, a smart waste management system. Basically it's one of the city in San Luis Obispo and Sonoma State, they wanted to monitor the level of the garbage in a garbage collector here, and then inform to the waste collection trucks to come and pick up the trash over there, right? So basically, because most of the waste collections or the garbage collections here in US, in most of the places is outsourced, So when it is outsourced, the contractors are coming up, right? Every day they come, or every week they go once, twice. I'm talking about the downtown or the park area, right? So city said, we are paying, heavy bill to them. So now why don't we, reduce that invoicing structure, or can you reduce some kind of an investment on paying for the waste collection? So then we came out with this systems. So it's basically, there is a simple system, right? There's a proximity sensor. It measures the level of the sensor, the level of the trash, and then it sends the message to the trash collector. We call it the trash collector, that this particular trash is full. Of course, with the Google map, this particular trash mounted and say in downtown or in the park, please go and pick up the trash, right? So we just go and pick up the trash and then go back here. Then immediately it goes to the cloud here, and cloud will go to the billing systems, and then we have a in SMS systems also. Then city manager will keep a track of it, and then the city manager will start paying it to the contractor based on this technology, right? Now, how do you make sure that this is very secured one, right? So this is where another one blockchain we are implementing it. We implemented it, but really not demonstrated because of this NIST, this pandemic. But this is another possibility, the research projects. Then it's a very simple project, right? It's and they got San Leandro City. We tried it. So they have got about 150 like this trash bin in the downtown, right? So they want to implement. They implemented it here for a few of them. So then once you implement a blockchain, everybody is trusted over there, right? It's implement a blockchain and everything. So that's one about it. And this is another smart street lighting. These are all coming to the smart city projects, right? Smart street lighting is you have the lights based on the object. You light it, right? I mean, you don't have to light all the lights, when you don't need it, right? Depending upon the object. I also see, in some of the remote places, right? When I go to in India, So we have all the lights. There no one is walking there. So you need to have 2 or 3 lights. And when if there are people are walking or if the vehicle is passing, okay, you can. It makes sense to switch on the lights, right? It's a smart street lighting. So you're putting on the street light for that. So then, of course, the LoRa is another technology. Low range technologies is not part of this conference, but LoRa is instead of Wi-Fi, you can also use this low range technology. We use the LoRa here, and then we have our own cloud, and then street light 1, 2, 3, 4 is lit based on the objects moving here, right? If you have one person, then I'll just monitor only one light. If I have multiple, then I multiple, and then like that we go, right? So this is again a part of that NIST program over there. And yes, that is about my some use cases here. So now some of the references here: IoT and blockchain press release to address COVID outbreak. So Internet of Things blockchain press release. And there are a lot many companies they're focusing or they're spending really money onto the the on the COVID-19 break, how you can use the blockchain here. So April 17th, there is a company called that Uber and the NASDAQ listed Centers announced their partnership on a solution for security handling the result of COVID-19 mass testing. So another thing is the COVID-19, how you are going to test, and then how you are going to make sure the test results are very correct and very securely connected. So this company is putting efforts to make sure that we get that connected. And then the COI said that collected epidemiologic and genetic data for 500,000 patients, right? The connected 500 patient data worldwide to date is work in progress, right? They keep collecting this genetic data, to create a system for testing the result in a secure way. It's coming up, right? So there are a lot of things happening in the blockchain and the IoT here. So my few just things, if time permits, then I can switch on to everything. Go to the question and answer, and then if time permits, we'll show some demo, or my colleagues will follow on the things. They have a session today, tomorrow, and day after here. Okay, so my few takes as per the Forbes, what is happening in the blockchain. The 4 components I picked up, they have given 5 components. The 5th one I did not understand, so that's why I did not put here, because I myself need to go through that one. So 4 one is that green blockchain initiatives, right? Because lot of talk is going on everywhere right now, how you have to be becoming green here, right? So your regeneration of the power, regeneration of the industrial IoT, regeneration of several things happening, right? So now the next high thing is that green blockchain initiatives, and more countries adopt Bitcoin and national cryptocurrencies. I did not talk about the Bitcoin because that's where the blockchain started, but I thought I looked into the agenda of whole conference is focused towards the IoT. I thought let me bring some IoT examples and share with you on. And national cryptocurrencies and blockchain and IoT integrations, we talked about that. And then the blockchain in vaccine manufacturing. It's a very, very, the upcoming research going on there. I know US government is putting a lot of funds and fueling a lot of companies to come out with their own technologies and own this one. So that's again reference from the Forbes. More details. I'm going to share this with organizer. This all my slides, so you will have this reference with you there. So with that, I will stop over here. If time permits, I can come back and show some live demo. But otherwise, I will stop here and ask the organizer to lead me on the time sharing. I don't know, because we are all faculty, right? We keep talking, right? I mean, this 1 hour class will become 1 hour 15 minutes, 1 hour 30 minutes, right? I just want to more constant to the timing. So, right, over to you, sir. Yeah.
Thank you, Shivkumar sir. In fact, we can't stop you. Your presentations are very nice and resourceful. So many of us know the technology, but to the end use of those technologies, you are given a wonderful presentation, sir. So thank you very much for joining us and for this keynote address. Audience, you have any questions? We have 1 minute time. please raise your hands and you can unmute and you can ask the question. Okay, thank you very much, sir. Audience, so very sorry because of 10 minutes delay, we are running with the schedule. So we are connecting to the next session directly. So please excuse us for the break, cannot leave. So we are continuing with the next session. Okay, so next session, we are joining with Dr. Swaroop and Dr. Sridhar. So now I will hand over the session to Dr. Sridhar to take away. Sridhar, sir, are you there?
Yes. You can hear me?
Yes, sir, we can hear you. Thank you, sir.
Yeah, hi. Good morning, good afternoon, everybody. So before I start this session, it will be like a dual session. So for next an hour and a half, so there'll be a 2 session. First one will be by my classmate and a very good friend, Swaroop. So let me give a brief introduction about Swaroop. I will not read out whatever he has shared. I will have to do some censorship about that. Yeah. So he studied with me. He was my classmate, and in fact, me and Chantal also. So we were all classmates in the same class, and it's my pleasure that we all 3 are in the same session today. And he did his bachelor's in SIT Tumkur, and then he did his completed his PhD in computer science in 2006 from University of Texas at Arlington. And then he worked for Samsung R&D for around 10 years, I think. And now currently he's leading the strategic technology efforts at Schlumberger. It's an innovation center based in Menlo Park, California. And his responsible is mostly, he's a very technical guy and trying to realize all those research work that goes in there. So he has both the research knowledge and also the practical challenges that you might face in implementing those research works. So he has around 30 plus patents, and we are all, and thanks a lot, Swaroop, for agreeing for this session, and we are all looking forward to it. Over to you then.
Awesome. All right. Can you guys hear me?
Yeah.
Is it audible? All right. Just give me a second. Let me see if I can get my slides up. And then
Thank you, Swaroop, for joining.
Of course. Nice seeing you, Shantala. All right.
So I think we should. I'll take a picture then.
Yeah.
Okay.
And while you're doing that, let me see if I can get my slides going. Hello. All right. Can you see the screen? Yeah, it's coming up.
Yes.
Just give me a second. It should be up, and I don't know how this works, but let's see. If I do slideshow here, too many sharing programs these days, so I'm never sure which one works better, right? So if it's not, just a second, maybe I'll just share the entire screen, and it's going to be easy.
That's better.
Screen 2. Yep. There we go. All right. Thanks for the introduction.
Hey, yeah. Just a second. It's still loading. Yeah. Now you can go ahead. Yeah.
All right. So thanks for the introduction. Thanks for the invite as well. It's a pleasure being here. Hopefully, I'll be able to share some of the learnings that I've had through the years, and then hopefully we'll have a few minutes for Q&A as well. Again, my name is Swaroop. I work for Schlumberger. It's a service provider in the energy industry, perhaps the largest in the world. Schlumberger operates in about 180 different countries across the globe. We basically have a presence wherever you have hydrocarbon assets, right? So oil, gas, natural energy these days as well, right? So that's kind of the context. I've kind of kept it at a fairly high level. I'm not too sure of the background of the audience, etc. I have significant experience in IoT. I've been working in the domain for a number of years now. but I'm a student of blockchains, let's say, right? So I'm not necessarily an expert there. It's essentially an attempt to kind of reflect on what we've tried so far and to share some of the things that we've observed. So what I want to do is kind of this, right? I'll share my perspective on how IoT has evolved in the recent past, and also give a bit of a very, very light background of basics around blockchains, and then kind of look at the overlap between the two, right? Are there opportunities for us to leverage one with the other? And then what can they unlock? That's kind of the context. Hopefully, it's going to be informative. And I'm going to share a couple of examples that we've tried within the industry as well, right? So in an abstract view, I'm not sure if the screen is okay. I see some fragmentation here, but I'm hoping it's coming across okay. Sridhar, can you confirm?
No, that's there even for us.
Okay.
Somehow on the right side for us, yeah, it's.
Yeah. Okay.
I don't know.
So,
why.
but anyway, I mean, while we are pulling it up, the point there is, IoT itself is kind of going through a bit of a transformation, right? Okay, is it coming up now? And hopefully it will stay this way. But anyway,
Yes.
so the term IoT is relatively new, right? Although we've had connected assets for a number of years. I mean, connecting a physical asset to a network has happened in the past, especially in our industry. It's been happening for a while. But then the emergence of the term IoT was because of a few things, right? There were significant kind of improvements in networking technology, connectivity, compute, et cetera, that made people realize that, okay, now we can really connect to devices of all shapes, forms, et cetera, to the network, and then we can start taking advantage of that, right? So that was kind of the realization in early 2000s, where the majority of the efforts were simply to connect a physical asset to the network, with the intent of gaining some visibility, having some basic management, right? So you could turn on, turn off certain actuators, or get some simple telemetry data from sensors, etc. So that was kind of how it started. And then from that, the immediate kind of next step, or the next step in the evolution, was to look at how do we optimize things. So now that we have the ability to connect to a particular asset, can we operate that better? Essentially, we're looking for things like OpEx, CapEx, OpEx optimization in most cases, sort of looking at same patterns to manage multiple assets. That's kind of what I refer to as rationalized management there. And then, looking at the ability to build apps, essentially introducing user experience to these classically dumb assets, let's say, right? So that was kind of one of the realizations that people brought into the domain. And then efficiency gains. So essentially, you had a particular asset that was built to do one particular function. Now you're looking to do it better. That was kind of what I call as the second wave of solutions in the space. And then, slowly we are maturing into a space where we are looking to actually create value, right? So not just run something well, but you're now looking at utilizing this connected asset to actually do a lot more. Essentially, kind of continuous improvement based on the asset that you put out there. And it's probably easier to see that with an example if my slides move. Yeah. So again, it's chopping off. So let me fix it again. But then just to continue, one of the classical examples of a IoT system has been the thermostat. I think in the past 10 years or so, we've all seen this being the poster child for IoT, right? And a lot of people probably remember the Nest thermostat that you see in the middle, but in fact, there was a predecessor to that around 2007. There was something called the ecobee, which essentially did similar things like the Nest thermostat. Essentially, it made the user experience a lot better, right? And it let you kind of programmatically set the comfort levels with the thermostat, and then you could operate this remotely. But then what Nest did was fundamentally different in the sense that it kind of brought in the ability for continuous learning, brought in the ability to, kind of help the user in the background, right? This is where it was learning continuously. So, the asset that you had there, you could operate it a lot more efficiently. That was kind of the aha moment that it unlocked. And then, a plethora of devices and services followed suit, right? But if you look at what Nest is doing today, the far right side of what you have here, the form factor of the thermostat itself might look very similar to what it was, let's say 10 years or so ago. But what it has unlocked as an ecosystem is a lot more powerful today, right? It's basically, when it got introduced, it was coupled with an application, mobile application that you would employ to interact with it. But now, it's grown into a bit more of a richer ecosystem. And essentially, it's now you have multiple products that you could integrate together in the Nest ecosystem itself. And they can basically talk to each other, essentially. So I have a smoke alarm in the garage, and carbon monoxide levels increase there. I get notified through my thermostat as well because I'm inside the house, right? So essentially, apart from being a thermostat, it now can be overloaded as interaction device as well, right? And it can kind of convey settings back to the other sensors, etc. So this is a typical or a poster child for what you could do with IoT. And even on the industrial side of things, we've seen similar transformations happen. Although it kind of has a lag in terms of maturity, it seems like the consumer product spectrum has a lot more happening there just because of the diversity of products there. But on the industrial side, we kind of see the same thing. So essentially, the fundamental observation or shift that you see is that you kind of were designing products for IoT in the beginning, but now there is this ecosystem, a platform view that's becoming a lot more prevalent, right? And this unlocks a lot of possibilities. From a compute perspective as well, it's becoming a lot more interesting. And hopefully I can share a couple of examples of what I mean by that in a couple of slides, right? So another way of looking at this is essentially the early versions of what we called as Internet of Things based systems is really centralized. You had many devices that were connected, and you primarily controlled them through an application, or even in terms of the data paths, you collect data on these devices and then push them into the cloud and make your decisions there. To what you see more of today on the right side is, all these devices that you have on the field, they have increasing capabilities embedded in them. So you can collect more data, you could process data, you could make localized decisions, you could actuate things in real time, etc. Right? So I think that is unlocking a lot more, unlocking a lot of very interesting possibilities in the kind of distributed sense as well, right? So with this, let's kind of shift gears. Let's look at blockchains for a couple of minutes. Again, as I claimed earlier, I'm no expert in blockchains. I'm simply a student. I see that the screen is kind of chopping off again, so let me redo the share. But in short, what blockchains are, they basically kind of a shared database, if you will, right? That are decentralized, that allow for multiple parties to interact or participate in a network of systems. And the beauty there is that everybody who's operating don't need to trust each other. The blockchain kind of gives you certain characteristics that you can depend on for it to be a trustless system, right? So what I mean by that is essentially there are ways for you to capture data within the data structure that's out there that will guarantee that the information that you store in there, once everybody agrees on storing it, can not be tampered with, right? And again, I'm sure through the workshop, you'll have many more sessions where people will probably talk a bit more about this. So let me just skip over this, right? So, but the fundamental observation again is one of the, okay, let me, I don't know what's happening here. So the fundamental observation here again is that from a networking perspective or from the systems perspective, what blockchains are allowing is kind of this decentralized world, right? So it's allowing you to kind of go from a centrally controlled system, your organizations or sort of entities of trust today, be banks or government institutions or many others, and all of us being participants here, we kind of depend on those centralized entities. We have the possibility to use this technology to go towards a bit more decentralized and distributed world, right? So essentially, it is liberating society in many kind of contexts, if you will. And that is true not just for finance. I mean, that's perhaps the most famous use cases of blockchain, as you all probably already know. But the fundamental compute infrastructure that it brings in is very exciting as well, right? But I'm sure you've kind of made the observation. I chose the graphics on purpose. Essentially, the evolution that we've seen through IoT is kind of very similar to what we're seeing or what blockchains are enabling as well, right? In a different context, obviously. But at the same time, because of the improved compute capabilities that IoT networks are having today, the ability to process a lot more at the edge and ability to make decisions, etc., it is now becoming possible to actually adopt things like blockchains and our everyday IoT applications, right? So that's kind of the intersection that is kind of unlocking a few new use cases. And before I talk about the use cases, I find this very fascinating, right? Again, coming from a computer science background, you've all seen the OSI stack, the networking stack, where it's kind of made it very easy for people to operate in a particular layer. You don't need to really worry too much about other layers, let's say, right? Because it kind of gives you that standardized representation of what's happening elsewhere, so that you can trust that and build your work on top. So there's an attempt to kind of do similar things for blockchains as well. Obviously, because of the contention that's out there, there are many representations of this, many alternatives, many possibilities, let's say. But in general, what this sort of a view, the layered representation for blockchain is enabling is it's simply lowering the barrier for entry, right? 5-6 years back, if you had to adopt this technology for one of your projects, you really had to adopt the entire stack. You have to start with kind of figuring out what is your actual blockchain, who's implementing your Merkle trees, and then figure out how to get a smart contract sort of a thing. That's kind of the application space construct. You really had to worry about all that. But today, you have kind of the maturity within the space is at such a level that you don't really need to build all that yourself or operate all that yourself, right? So a lot of these are available as services that different vendors and different parties are operating, and you could focus on a particular layer where you think you can add value, right? So again, I'm sure you'll hear more about this through the workshop, but I find this very fascinating, right? It's enabling a lot more because people can approach this a lot more. It's become a lot more approachable. Let's put it that way, right? So again, the very short introduction of blockchain and how it can be used. With that, I'll shift focus a little bit. I'll share a couple of use cases that we have worked with in my org, and kind of again give you some that'll kind of give you some flavor of what is it that we are trying to unlock, right? And kind of forewarning there is that all the things that I'm sharing today, they're early efforts. They're not yet very mature. We've not necessarily deployed this anywhere, right? So these are kind of what you could refer to as proof of concepts, right? That's kind of where this is. So the first use case that I'd like to share is, is the emissions tracking use case. So the picture that you're seeing here, it's an aerial picture thing taken from an aircraft, and all these little patches that you see on the land, they're all well pads, essentially oil fields, and in the middle of each of them there is a well, right? It's an operating well. Essentially, that's kind of where you draw oil out of, and then they flow through different pipes into a refinery. That's kind of the setup. Now, what's happening in these cases is that the equipment, they sit out there for 20 to 30 years at a time, and over time they degrade, and there's leaks happening. The wells themselves change their characteristics. They kind of stop producing oil. They produce other kind of gas and other things. And essentially there is emissions, right? So not kind of greenhouse gas emissions. Which is problematic. Essentially, there's a need to kind of monitor that, track that, etc. So that's kind of the context, right? So that's something that is quite useful in the industry or in general. And for that, again,
Swaroop,
yeah.
Hey, can I share my screen so that it's still chopping? So
okay,
I have your slides. I will share my screen so that you can speak on that.
Sure, let me stop. Go for it, yeah. So and while Sridhar is pulling that up, let me also share the context here, right? So typically the geography that you saw there, that large patch of land, it's really operated by multiple operators, right? So
is it okay?
Yes, I can see it. Hopefully others can. Right? So essentially, these are large geographies, and then the real estate there is owned by multiple operators. The infographic here is kind of depicting A and B. There could be multiple clients of ours, and there's a need to really track information or track the emissions across multiple clients, right? So because again, there are regulations being formed around this. There is a need to kind of be carbon neutral going forward. So this is an emerging need within the industry. So in this setup, the traditional way to kind of achieve this would be for us to ask both A and B to kind of take localized measurements and then report them to a central entity, which would really compute what's happening, who's emitting, who's not, etc. But the technology is mature enough for us to kind of observe the data all across, correlate that with weather information, essentially how wind is blowing. And when you correlate the two, we kind of know, if there's a plume of gas, a plume of methane floating around, we can predict or we can track it down to which part of the geography it originates from, right? So that's the context, or that's the possibility. So a particular effort that we were doing here, again, in a fairly large scale, was to kind of figure out if it's possible for a ledger to be operated where multiple clients of ours can publish, and they all become kind of participants within that shared ledger setup, right? And technically this is possible. Obviously, there are lots of operational challenges that we kind of are dealing with today, scalability, cost, etc., which we hope to solve in the near future. But the exciting part is really the ability to kind of adopt this DApps, or distributed application possibility, for us to introduce other things as well, right? So with this, we can kind of bring in the notion of carbon offsets. Essentially, the idea there is that if you're a polluter, you can purchase carbon credits from somebody who's capturing carbon, right? Like maybe a national park that captures carbon dioxide, monoxide, and then turns that into oxygen. And this is a global scale kind of an opportunity, right? So things like that are becoming possible. Again, not yet there, right? The next example that I want to highlight is what we call as edge vision. And the fundamental tenet or enabler here is, again, kind of the IoT side of things, right? So on the devices that we're witnessing today, there is kind of a growing capability. In this particular example, we have CCTV cameras that are IP enabled, and we can embed certain compute within these, right? And that will allow us to run advanced algorithms on the cameras. And in this case, we're interested in the primary use case for this is safety. Essentially, we want to know if somebody falls down, we want to know if there's a fire hazard, we want to know if there's a spill in a facility, that kind of a thing. And the idea is that you have, computer vision based machine learning models that are detecting these individual events, and we could push those to be executed on the camera, right? So that's kind of the enabling technology here. And then what you see on the right-hand side is the application of that, what we call as health, safety, and environment, right? Sridhar, if you could go to the next slide. So the same enabler applied in a different setup. What you see here is a frac site. Fracking is a fairly logistically heavy operation. What you see here are all trucks that do very different things, right? So one of them, or a set of them, might be pumping water. Another set of them are pumping mud. Some others are pumping some other fluids, chemicals, etc. So all this is necessary to actually get to the hydrocarbons that are hiding under Earth's surface, right? And the gray thing that you're seeing at the behind or kind of the top left corner is a control center. Essentially, that's all computers, right? So that's kind of controlling a lot of these things. Now, in this, even with all that compute that is available there, most of the logistics of what truck goes where, how much water came in, how much sand came in, what sort of chemicals, how much of that went in, all that, believe it or not, is all manual, right? So somebody's writing down, they're entering things into spreadsheets, etc. And in most cases, all these are provided by different vendors, right? So essentially, there are multiple systems, information systems that are capturing kind of disparate sources of or pieces of information, which needs to be collated later for us to complete the operation. Yeah, go to the next slide. So again, we are kind of using similar technologies in a setup like this. What you see here on the left-hand side is a computer vision model that simply counts pipes, right? So pipes are a fundamental or very integral part of this fracking operation. So we want to keep track of how many pipes, which set of pipes are where, that sort of a logistical need. And we're using computer vision and a couple of other mechanisms to track the usage of those. And then on the right-hand side, what you see here are kind of zones that we've defined again through the cameras that are there, which are areas of interest. So we want to kind of understand what is happening in these areas because they're very specific, assets that are placed there, right? So, again, this could be, this is a separate application on its own. We kind of have certain use cases there. And then we have models that let us kind of count people, understand where they are, how much time they spend, etc. Now, the ability to kind of bring all this together for us to really automate the logistics of the entire site together is a very exciting possibility, right? And that's kind of what we are after. Is the ability, and again, because of multiple vendors, multiple parties operating in the same site, we don't have control of everything here, right? But we are in a situation where everybody wants to automate this because of cost, because of efficiency gains to be had, because of new possibilities that we could unlock, right? So that's kind of where we are headed with this particular use case. Shreya, can we go to the next one? Yeah, then I was just paraphrasing this. Essentially, we want to kind of eliminate all the things that you see on the right here, large paper trails, the error-prone nature of operations today. We want to kind of take advantage of technology. Again, here, the idea is that we would operate a shared ledger within this frac site, and there is enough kind of happening there for us to look at this as a fairly rich set of data that can get in and that we need to track. Again, earlier efforts, we proved that it's possible, but not necessarily ready for production, let's say, ready for industrialization. That's kind of where this particular use case is as well. And then there are many more. Logistics on its own has wide applicability across industries. You could do a lot more. You could kind of track where the materials are coming from. You could really go back to the source of how they were made, et cetera, et cetera. And you probably have seen descriptions of those in different places. But the idea is that these things are becoming a lot more visible and possible because of the technology maturity. That's kind of where we are, right? And based on what we've seen so far, based on what others have been reporting as well, I think there are a few scenarios or a few requirements that you would want to look at before kind of adopting blockchains. And this is in general, this is not necessarily specific to IoT. Essentially, you want a scenario where you have multiple parties that are operating. There is a shared data structure. There's a need for a shared data structure. There's a need for multiple parties to come to a consensus, and existing mechanisms are proven to be too costly or impractical. That's kind of where you would want to consider applying blockchains. And at the same time, if you have a need to store confidential information, again, in the open, right? In the classical definition of blockchain, it's probably not a good idea. You really need additional mechanisms to first encrypt the data that you're sharing. Essentially, that becomes the block that gets stored. And when you audit it, you really need that original participant to come and verify that nothing is tampered with as long as the core data is concerned. And a few others, right? If you are operating static data that doesn't change, that nobody's operating or nobody's accessing frequently, there's no point really using blockchains to do anything with them, right? So a few of these things are things to be kept in mind. So in summary, again, I'm kind of rushing a bit, but in summary, IoT itself is becoming a reality, right? So a few years ago, you probably had seen infographics claiming IoT is going to transform everything. It's going to generate billions and billions of dollars in revenue. We perhaps have not grown in that sort of a pace, but we are on track, right? So we have what we call as classical IoT devices. Those are proliferating, but in the enterprise sense, the emergence of edge computing, coupled with what's happening in IoT, is becoming a lot more practical for us to scale things with, right, and to approach programmatically. So that's very exciting. Again, edge computing is real. It's going to be bigger than what you see in the cloud today, just because of how it is unlocking use cases, etc. In our case, basically the last mile, of networking typically is our first mile, right? Because that's where our operations are, and edge computing is really enabling us to do a lot more in that sense. And in the overlap between kind of IoT and blockchain, again, there are unique capabilities that we could take advantage of there. But I think the most exciting thing for an industry like ours is the lowered barrier of entry, right? So we could really take advantage of an existing system, and then we could build our solutions on top. We kind of can encode our rules and then take advantage of the fundamental capabilities that blockchains offer for us. So the where we are at right now is that we are cautiously optimistic about applying blockchain in IoT, and there are a few things that need to happen, but we believe that's going to happen, and I think there is more to be done in the domain, more to be kind of realized as potential for industries in general, right? So that's kind of the optimistic part there, right? So maybe next slide. Is that it? Yeah, that's pretty much it. Again, so there are some open challenges, in terms of how one needs to scale the blockchains, what sort of consensus works better, what sort of energy is spent in keeping the blockchain alive, etc., which is all kind of being debated, being worked on, right? And all those are very interesting academic problems as well. So, a very exciting field. Many things are happening in the domain. We should see a lot more happening, coming out of this particular domain in the next couple of years. That's kind of where we are today, right? With that, I conclude the talk. Thank you. I'm not sure if what the time is, but I'd be happy to answer a few questions if there are any.
Hey, thanks a lot.
Sure.
If anybody has any questions, how come there is an echo? Okay, so if anybody has any questions, please post it in the chat. I will pass on. Especially, I personally found it very interesting, Swarup. So thanks a lot. I have a few questions.
Sure.
Of course. See, first is I find it interesting because in morning my daughter was watching some Netflix show. There a bunch of kids go to school administration and they request for a fracking near their school. I mean, the administration tells, do you have any idea what it costs to do the fracking? So I had no idea what fracking is. So I noted down, I decided to Google later. But now I was looking in your presentation, you're talking about fracking. So my questions are, first is, you showed some use cases, right? I mean, are they active and are they recent, or it's still ongoing, or it's kind of a past thing?
No, it's fairly recent, right? the emissions use case is something that is emerging. It's very early stages. Again, the cost sensitivity is the biggest challenge there. The others also fairly recent, right? Where they are at is, we're very sure that we're going to apply fundamental computer vision-based solutions there. But then the next step in automating the entire logistics is a question mark, right? So there are a few other ways to do this as well. You don't really absolutely need blockchains today because it's, again, kind of isolated. There's a well-defined perimeter for the problem. But if the technology matures and it gets adopted in other parts as well, as I was saying, if the warehouses where these chemicals, fluids, etc., come from, they start adopting it, it makes a lot of sense for us to integrate with that, right? And so it's more of a network effect that we're waiting for in that sense. And it's also an opportunity. And if we crack it and we can deploy it to our vendors, our ecosystem, that can happen as well. But it's kind of early stages even there, especially blockchains. Yeah.
Okay. Okay. And for solving this, the problem that you mentioned regarding the fracking and creating the automation and all those things, typically, what is the timeline? For example, if you want to give a rough estimate to solve these kind of problems in an end-to-end way, we are looking at in a year's time, or how is it? A year, right? More.
Yeah, I mean, it's typically more than that, right? Again, there are two parts to it. One is the technical solution, the other is adoption. It's easier to build a technical solution and demonstrate how it can work, but then the adoption, there are a lot more variables, right? So cost being the primary one, and a lot of this is cost sensitive, right? So we need to get to a stage where through technology, we can optimize it so much that we can demonstrate out of the box kind of efficiency gains as well, along with the rest of what we're doing, right? And I think we're not there yet in that sense. But it'll typically, it's, a few months to demonstrate the possibility, and depending on the business climate, it could take a few years for it to get adopted, right?
Okay. Hey, you can see my screen, right? There are some two questions. Can you see if you can handle?
So the second, Ravi has asked, in which layer does the blockchain work, right? So again, the layering that I was referring to, this is kind of very much native to blockchains themselves, right? So all these things that you see here, these are kind of people trying to define layers for blockchain. These are not necessarily networking chains, but the fundamental data structures for blockchains are layer 0 and layer 1. Layer 0 is more infrastructure. Layer 1 is where your kind of proofs work, where your fundamental tree structure, the chain itself lives. But interestingly, the layer 2 solutions, there are many. I think there is a very famous one out of India called Polygon, and that's a layer 2 solution which is very attractive because it's allowing you to scale the blockchains independent of what's happening in your main chain, right? The problem today is that for you to scale things on your main chain, it's very expensive. The gas in the Ethereum network, which is another very popular blockchain network, there is something called as gas. Essentially, it's the cost that you pay for transacting with the system. So for a particular transaction on that network, you end up paying a lot of money, right? So the focus of layer 2 solutions is to minimize that interaction, minimize the number of times you need to talk to that main network. So what they do is they typically they create something called as side chains, where they have different philosophies of how they admit information into their chains. And then it's usually a lot more economical to do that, right? So they kind of build blocks on the side chain, and they kind of take the entire chain and then park that onto the main chain so that that becomes globally available, right? So there's some smart ways in which people are approaching this. But then the layers themselves, depending on what you're trying to do, you might live in one of these layers, right? And as I was saying earlier, if you're an application developer, you want to really encode a particular logic, you don't really have to go into the depths of what blockchain is doing at all, right? So I think there's a programming language called Solidity, which is kind of on the application layer, which lets you encode a distributed application, which you can easily pick up in a couple of weekends and then start coding distributed applications. It's become that straightforward today, right? But for you to adopt it on the whole, there are still question marks. That's kind of where at least I see things at, right?
Yeah.
Okay.
So there is no simple answer like a layer kind of a thing.
No. Okay. The next question we have is this technology suitable only for small range and low distance tracking? I'm not sure what this refers to. Is it the emissions use case? If that's the question in general.
Sure. So, Guru Baswana, can you clarify? In the meantime, we can quickly.
Sir, range means with respect to size. Size, I'm talking, sir. Size of the data.
Size of
the data
for blockchain.
Data size. Yes, sir.
Well, so that's the beauty, right? The chain itself doesn't really care about what you're storing there, as long as you can compress it or you could represent it. However, you can actually arrive at fixed size blocks today. And this is where the side chains and layer 2 solutions are shining, because they can adopt some very, very interesting ways to capture data and produce a hash, right? And as long as you can keep that hash in a tamper-proof ledger, you can achieve the fundamental tenets of blockchain. And that's kind of how practically people are solving this, right? But
so
the main chain
for a large
itself,
bandwidth, sir? Will it demand for a large bandwidth?
The blockchains themselves, not necessarily. It really depends on the transaction frequency, right? If you're transacting very often, you probably need more bandwidth. The challenge is really consensus, right? As the network size grows, you want more people to vote and say, hey, this is a legitimate transaction, right? And this is a fundamental challenge today. There is kind of contention between proof of work and proof of stake. And one is more efficient in terms of energy than the other, while the one kind of gives you more guarantees in terms of saying, okay, this is a legitimate transaction, versus another where it kind of adopts some trust models, right? So there is a trade-off that you're playing with, if you will, right? Does it make sense?
Thank you, sir.
Awesome. And what kind of research is going on in terms of energy efficiency of blockchain network, as it is gas heavy, as you told? Well, that's an interesting question, right? I'm not necessarily very familiar with all the blockchains, but there are certain solutions in main chains that people have come up with, which claim to be extremely energy efficient. But I can't comment on why they are, right? I'm not well versed with kind of fundamentals of those. But there are solutions today that claim to be a lot more energy efficient. In fact, for carbon credit monitoring, which is again a carbon initiative, right? So you could imagine the sustainability goals a project like that will have. They're actually trying to adopt a blockchain-based solution to solve that, right? So where they really have to intrinsically prove that the solution they adopt is not spending more than what they're guaranteeing in terms of credits. So it's there, for one to kind of go and read about or figure out. But I'm not an expert. I don't know what exactly is happening there. But there are certainly things happening, right? That's where things are.
Yeah.
All right.
I think we will wind up now, Swaroop. So thanks a lot for your time, and I think it's really late for you. Thank you very much. It was really interesting. I think going by the questions and interest, you can really understand. People really enjoyed your session.
Awesome.
Thanks again for your time. And you actually helped me to pick up from where you have stopped on edge computing. I think so. If Swaroop is, of course, he's an expert in IoT and is a student in blockchain. I'm a student of both. So I will continue from where he has stopped, and I'll focus more on because my work and research is around cloud, and I'm a networking guy. So I will take up from here for the next 30 minutes. I'll be speaking on. I'm already sharing. So thanks a lot, Swaroop.
Thanks a lot,
Good night,
Swaroop.
guys.
Yeah, good night.
Thanks very much.
Thank you very much. Yeah.
All right.
Bye.
Bye-bye. Thanks, guys.
Bye. I will share Swaroop's contact, so if you have any questions, you can feel free to connect with him. Yeah. So as I mentioned, what I will be speaking in next 30 minutes is how this technology, the Kubernetes, I just shorten it as K8s, how this technology Kubernetes is becoming more and more important in for these two IoT and both IoT and blockchain, and why it is important. I think. So the main message, the takeaway message for today from my side is basically Kubernetes is becoming a must, and in implementing IoT and blockchain solution, and it helps to know and get comfortable with it. Right. In fact, in some organization, if you want to really realize these solutions, there's no other way other than this one. You will have to get comfortable with this technology. So I will start with what is this Kubernetes. I'm not sure if everybody in this call will be aware of this thing. So before I directly jump into Kubernetes, I would just want to give some spend some 5-10 minutes on this fundamentals behind these things, like microservices and the containerization, and then introduce Kubernetes and quickly cover how this Kubernetes is playing a role in both IoT and blockchain. So that will be the overview. Because if I directly go ahead and say, hey, these things are realized as microservices and they're containerized and run on this Kubernetes, not many in this call would be able to understand and appreciate. So I'm spending some time on giving a brief overview of this microservices and containerization. Yeah. So over the past few years, this has been a kind of one of the buzzwords in this domain, especially when it comes to software architecture domain. And really, this is not a new thing. And, the service-oriented architecture has been there from past more than 15-20 years. But the way of doing it, service-oriented architecture, is what this microservice is all about. It's a software architecture paradigm. And it has been, as I mentioned, it has been a very important, especially in the containerized world, to realize your software applications as a collection of services. That's when it really makes sense to containerize and your applications. Okay, so what is this microservices architecture? Basically, we are all familiar with monolith application, like written once kind of a thing, and it has been even today. It's not a bad approach, and a lot of people still do monolith approach. This is software architecture approach, but what happens when the number of users and the things grow, right? When it grows, when it scales, how do we handle the scalability problem, right? So when to address this basic scalability problem, right? This scale cube is typically referred, and there's a very good book by Abbott and Fisher on the art of scalability. Okay, so he considers this scale cube. On the x-axis, you will see that one of the common approach to handle scalability is create multiple instances of that. For example, if you have a booking system, right? So take an IRCTC case. So if you want to have a booking system like that, if the number of users increases, you create multiple instances of the same application running and handle different users by different instances thing, right? So this is the horizontal duplication thing. So this is called as x-axis scaling, right? And this the z-axis scaling is similar to x-axis scaling. The only the significant difference is the partitioning of the data, right? So the data is typically partitioned, and different instances use a different set of data, and they handle this scalability problem. But what focus of the microservices is around the y-axis scale, right? So you decompose a single service into a multiple service types, and each of these services can be scaled and handled in a different way based on the requirements thing. So microservices is all about this y-axis scale, the functional decomposition. So you functional based on the functionality, you decompose your singles architecture into a bunch of services, right? So if you take any, for example, like a version of an Amazon which handles the ordering and everything, the whole single application is broken down into collection of these services thing, and each of the services talk to each other in a well-defined manner, right? It could be your REST APIs, which are more commonly used, and there are a set of rules also how to implement like a 12 factor approaches kind of a thing. So a lot of research and effort has gone over past 2-3 years to come up with this clean definition of these microservices. Basically, you will find a lot of definition online about what this microservices is. It's basically small and autonomous services that work together. Sam Newman, and he rephrased the same definition into independently deployable. So he focused on the problem of deploying these services independently and that work together, right? And the main focus should be on the business domain or the problem that it's solving. Okay, it's again a software architecture. It's a suite of collaborating services. So you will find these different services. At the end of the day, the idea is pretty simple. You will have to instead of a monolith, you break down your complete into a functionalities as a collection of services, and these services talk to each other in a well-defined way, right? And a simple definition would be service-oriented architecture done right. Okay, so this is a quick overview of what microservices is. Why I am started with microservices basically is if we are talking about containerizing your solution, it is better to use this microservices way of doing it. Now, why are we doing containerizing application? I will focus on the next part where I want to introduce start with virtualization thing. Okay. So this virtualization has enabled the whole domain of cloud computing, right? We all know this is the underlying force that has made this cloud computing both feasible and growing as an right. And we all are aware of these things. So let me quickly cover what this virtualization, what is the kind of virtualization that we are talking about in this today's session. So imagine if you have a computer, right? It could be, and resources, a collection of resources that a computer has. Mainly we focus on compute, storage, and network as the resources of any computer, right? So imagine it has like 12 cores and 32 GB RAM and 1 terabyte hard disk and some kind of bandwidth network connectivity, you have it, okay? And usually on top of this, we run an operating system. Yeah, we cannot escape that part. And there is one kind of virtualization that what we call it as a hardware level virtualization. To realize that virtualization, we need a piece of software called as an hypervisor. And you would have come across different hypervisor like VirtualBox, Oracle VirtualBox, or Aquemo. And typically they need a counterpart in the operating system level also. Sometimes it's one of the examples is a KVM at the kernel level. And they help us to create what we all know as virtual machines, right? And for example, you can assign for that virtual machine a slice of your resources that you have in your computer. For example, you can say, I will create one slice with 4 cores and 8 GB RAM and 500 GB hard disk. And you can assign this slice of resource to a virtual machine, right? And create a virtual machine. And we know that virtual machine comes with its own operating system and collection of libraries for the application and the application itself on top of that, right? So this is called as usually referred as a hardware level virtualization, because the virtual machines that are running, they may not be aware, or they think that operating system, they think that this is the 4-core and 8 GB RAM is the hardware that I am working with. He may not be even aware of he's running as a virtual machine. Of course, there are options to make him aware. And typically in this environment, there is usually a piece of software again called a libvirt kind of a thing, which will help you to interact and work with these virtual machines, okay, or this virtualization of resources. Now, there's another kind of virtualization, which is the focus of our topic, is the operating system level virtualization. So in this case, these kind of virtual systems, also called as containers thing, they share the underlying features of the operating system, right? That the core kernel components of the operating systems are shared, and it comes with its own collection of libraries of applications and the application itself, right? So these technology of containerization has been there for many years, and over last few 5-10 years when the Docker formalized, and you would have heard of the term Docker, I think. So it's a kind of becoming a de facto. It's already a de facto standard by now, and there are, of course, there are other technologies apart from this Docker and Linux containers. But let's focus for today as this thing. And this is usually, as I mentioned, it's referred as OS level virtualization, right? And why containerization? I don't want to go into details in that. Of course, it's the lightweight, and its footprint is small, and all those things. And it's easily we can manage and control these things. Now, the technology that is used, if I had only one server, right, it's very easy for me to run a Docker container and handle it and manage it easily. But if I have like hundreds and thousands of nodes, computers, to managing these containers across these multiple hundreds of nodes is not a straightforward job, right? That's the same case with the virtual machines also, right? So there the technology called as OpenStack is very popular, that will handle that problem for you. Whereas in the container world, there are different solutions. For example, Docker itself has a solution called Docker Swarm. But the technology that we will be focusing in today's session is the Kubernetes, right? So Kubernetes is the solution that will help us to do it. Before I come to the Kubernetes thing, I just want to quickly relate to the previous topic of the microservices and mention, if you are containerizing your application, right, you will have to focus on some application design principles. Okay, so this the first is, of course, the single concern principle. So each and every of your containers should focus on one responsibility only, right? You cannot have multiple responsibilities for a single container thing. And every container or any this workloads application should be exposed itself to a lot of observability. I should be able to monitor, collect metrics and logs and all those details. And the next is on the lifecycle conformance principle. Like this container should be able to listening to these events and handle these events, kind of a stop or a start and these kind of events, and to respond to those events accordingly. And the next is the image is the mutable. So each of these images are immutable, and it should be able to run across different use cases or environments like development, test, and production. Right? I think, yeah. So let me continue. Okay. So, and we also have this process disposability, which each of these containers are very ephemeral. They can start and stop and go. And the self-containment. This principle focus more on the build time. So whenever you build a container, all that is required for your application along with this library should be part of that build. And the last one is about the runtime. So whenever you run your container, you should really understand what are the resources that it requires and try to assign and allot those resources to them. So these are the quick summary of the principles that you should focus if you're containerizing your applications. Now, let me quickly summarize what I have spoken till now before I continue to the next one. See, we have focused on, it's important to focus on the microservices based architecture, because if you are focusing on containerizing your application. Now, it's required to containerize your application because of the lot of advantages it provide, and the technology that is used to handle these containers across hundreds of nodes is Kubernetes, which we will see quickly. And again, just to recap, I'm focusing on this because today, for both this IoT and this blockchain domain, all those applications that you are running in this IoT and blockchain, they are all containerized nowadays. Where they are containerized, we will quickly see. So this is where I'm standing as of now before I move to the next one. Okay, so as I mentioned quickly, it's a solution. It's a software system that helps you in automating the complete life cycle of the containers across hundreds of nodes, right? So it helps you to managing these containerized applications. Okay, so as I mentioned, it's running containers on a single system is easy, but across this multiple nodes, it's not so straightforward. There are various challenges in discovering resources, handling those resources, and allocating these resources, and of course, handling these applications. Okay, so it's of course from the Google's effort of like 15 plus years, they had this project called the Bob, which was kept secret for a long time. And this Kubernetes came out of that effort from the Google, right? And as I mentioned, there are other solutions related to Kubernetes, Docker Swarm, Rancher, Mesos, and Nomad. But most of them came out of this, the idea from Borg that was part of the Google's. Okay, so the Kubernetes architecture is very simple. We have what we call it as a master or a manager on this side. So it has like a 4 main components. One is the API server, which user can talk to this API thing, and there's a scheduler and the controller manager, and a distributed data store called etcd, right? So this controller, this manager, are usually referred as a master. So this node will handle all the worker nodes from where you want to deploy your containers and manage your containers. So on each of it just has a manager and a set of nodes, which usually called as worker nodes. And each scheduler will decide how to and where to place these containers in your cluster. So this manager and your worker, the set of these nodes is usually called as a Kubernetes cluster. And you will constantly hear this term Kubernetes cluster whenever you come across the real world implementation of both your IoT and blockchain going ahead. And this API server and persistence layer, which is your etcd, and the API server will help you to interact with this cluster. Okay, and we have this controller to managers, and you can deploy this cluster on different kinds of infrastructure, whether on your laptop or in your a bunch of servers, or on OpenStack itself as a virtual machine thing. So it can be deployed on a different places. So even on Raspberry Pis, the Kubernetes cluster is set up, and that's one of the use cases in some IoT where they deploy this Kubernetes cluster and put this cluster using Raspberry Pis. Okay, this is just a summary of the complete Kubernetes architecture. I have this master node here. It could be more than one node also for the redundancy, and a bunch of worker nodes, right? So this master will ensure and decide where all my workloads, my containers will go, and manage those containers or your applications accordingly. Okay, so that was the quick overview of our, the information. For the next 10-15 minutes that I have in my clock, I would like to focus more on how this Kubernetes is being used for both IoT and the blockchain. Okay, so just a recap. I think so. What has been known, we all know now. In fact, both Swaroop and Shiv Kumar has spoken about this thing. When it comes to the IoT, there are a growing number of sensors and smart devices generating terabytes of data, right? And there is a need for reliable processing of these data. And to solve this problem, sometimes the cloud platforms were introduced, and all these data were moved for the large-scale processing of data. All the data were moved to these cloud platforms. And today, all hyperscalers like Google's and Amazon's and everybody offer IoT cloud platforms. Okay, and the importance of like both. Can you give me 1 second? 1 second. I'll. Yeah, I'm sorry. Let me go back to that. Okay, so what we have, we know is this is what the trend, that is the use of cloud, the importance of the cloud in IoT. A lot of data moved to the cloud for the processing, and all the hyperscalers offer this IoT solution. So we know we are aware of the importance of this cloud computing in IoT and high computational processing and problems that it is solved, and these are all well understood, right? And even we know that edge computing is over the last few years, it has risen into a lot of prominence, which will help us to solve the problem of a quick processing and local processing of the data and handling of these gateways. As Swaroop mentioned in the previous talk, for them, for their organization, the edge computing, which is mostly at the last mile that happens, is the first mile for them. And they work and they see a lot of changes that is happening in this edge computing domain. And the main message that I want to convey in this Kubernetes and IoT is the introduction of these Kubernetes clusters at the edge also, right? So it has, of course, even, for example, many of these hyperscalers in their IoT cloud platforms also, even those platforms are running as Kubernetes cluster, right? And more importantly, on these edge devices, edge side also, we see a lot of Kubernetes clusters that are coming up. So that's my main message. And when it comes to focusing more on the edge computing, like we know that because of the increasing number of the millions and billions of devices, it would not be feasible to move all the data to the central cloud. That's where the importance of the edge computing came into picture, and it facilitated and introduced a lot of use cases also, right? A lot of applications also came when this edge computing came into picture, because at the local itself, I could process some data and handle some and realize some of the applications. So and it addressed many challenges. It's all the latency is lesser, the privacy is still there, and network load is reduced, computational efficiency, and autonomous. Okay, so before I move on, I just want to focus. Edge can mean different things to different people. I was just looking at this diagram. So if you have this bunch of edge devices and the edge gateways, right? And we can have multiple layers of these edge nodes that are happening, and edge data center and the central public cloud kind of thing. So we would be focusing. This is what our last mile is, right? And the Kubernetes has penetrated into all at all of these levels. In fact, right? So there is a kind of some kind of a cluster that has been getting deployed across each of these levels. Okay, and if you from the bottom, if you see the bottommost layers will focus more on the device connectivity, and as and when you move high, it is more on the device management and the data management problems come into picture, right? So this is the typical architecture we have seen. Thanks to this is from the Bosch architecture that I'm showing. So we have the bunch of edge devices and the connectivity technologies, and this is the IoT edge solution that a lot of vendors are coming. Bosch is just an example. There are so many other vendors who have come up with this thing. And of course, when Shiva was mentioning, you can also directly pass the data through either to MQTT or HTTP to the cloud services thing. So the penetration of Kubernetes over the last year or so has been more in this domain, and it is still happening. And a lot of Kubernetes vendors have entered this domain and offering the IoT edge solution based on Kubernetes. Okay, so why? Because on the edge consideration, typically I have tried to enlist looking at the consideration. Typically, people focus on the edge. It can solve whatever I have highlighted, like the availability and reliability, and you can scale it. And some of the analytics and the applications that you can bring, for example, Kubeflow is getting very popular on the edge. I mean, the IoT use cases also, where AI and ML solution based on Kubeflow is deployed on the edge, right? And integration with the custom applications and device abstractions and digital twin. So these are all the very popular use cases that have been solved. And it is the next big thing at the edge. Okay, and over the past few months or a year, a lot of work has gone. And if your interest as an attendee in this workshop, if you are interested in the practical realization of IoT or even the blockchain, you may have to invest some time on Kubernetes. Okay, so finally, so summarizing this edge computing trend at the IoT, we now the edge computing is more of a combination of IoT gateways and hubs, which is a more traditional component, which is single system IoT devices that would collect the data, which provides us the resiliency and the reconfiguration. In fact, most of these are very robust and resilient. And it's a fundamental component, right? So it has been complemented with what we call it as a micro clouds, or our small Kubernetes clusters that are coming up thing. And they are these very small clusters with very few collection of compute nodes with the storage and local storage and networking. And its focus is on redundancy and scalability. It provides you the redundant, because Kubernetes per se by inbuilt, it provides you the redundancy, I think. I didn't want to get into those details of how Kubernetes provides the redundancy and thing, but you may have to go through those things in detail. Considering time, I had to cut short on those redundancy and scalability. It's a new class of infrastructure that is coming up, right? So there are a lot of effort and work going on. You will see more in future. This new class of infrastructure, many people refer it as a micro clouds. I'm continuing to refer it as a micro clouds. They are all based on Kubernetes. Of course, I have seen some of the cases where they are also based on OpenStack. It's like a minimal version of OpenStack, because they want to run virtual machines. And because Kubernetes can also run virtual machines now, people don't want to go to OpenStack, because Kubernetes can handle both virtual machines and containers now, right? In fact, not now, maybe from past year or so. Okay, IoT gateway, I don't want to spend much time. You're all familiar with it. And because in the next few days, a lot of people will be talking about these IoT gateways and things. And this is what my summary and focus is on the micro clouds, right? So it could be a small set of computing nodes. I also mentioned earlier, it could also be a bunch of Raspberry Pis, right? And they run all these applications are containerized and they are run as microservices, right? So hence I wanted to introduce what do we mean by containerized and what do we mean by microservices in my initial slides. It will help you for selective scaling. Selective scaling has been a very, very interesting use case. So there are small managed clouds that are decentralized, right? So that's the quick summary of thing. In the remaining few minutes, I would quickly summarize the blockchain use case, the Kubernetes, right? So over the last year or so, as people mentioned, blockchain is just a, I don't want to use it just, it's a distributed database, right? It's I think Shivakumar also mentioned the word ledger, and everybody will be mentioning the word ledger. It's a shared immutable ledger, right? And it maintains a list of operations or the transactions, that the history of transactions, which are added in a chronological order based on the time, right? And it's a distributed one, okay? So in order to deploy these applications, right, you need some kind of a distributed ledger, hyper ledger, what we call thing. And on any choice of infrastructure, you can pick any infrastructure. Okay, but the trend over year or so has been to use Kubernetes. Okay, why? Because of the deployments. It simplifies the deployments, and most importantly, it can manage your complete life cycle. Okay, whether you want to scale it up, or you handle resiliency, start and stop, and manage complete life cycle management, right? And finally, the interoperability. So these 3 points have driven to go to fall back to Kubernetes to deploy your blockchain network. Okay, so even providers blockchain platforms, in fact, almost all hyperscalers, again, they have this blockchain platforms. They also run on Kubernetes. Right? Similar trend that what you saw in IoT also, both the provider of IoT platforms and the edge, at the edge, the Kubernetes is dominating. Similarly, the providers of these blockchain platforms and if you want to deploy your own blockchain network, the Kubernetes is been dominant here now. So if you look at today's in any open source projects that you have, whether it's Linux Foundation's Hyperledger, or it's a Corda or Ethereum, you will all find there is a use case where they have been deployed on Kubernetes. Okay, and it's also easier for you. For example, you can set it up in your laptop and set up a small cluster in your laptop, and you can try deploying this Hyperledger or Corda or Ethereum on your laptop itself using a cluster. So maybe extrands when there in the next few things. I wanted to check with Shivkumar. So maybe they might also support on their platform, on their hardware platform, whether they can run Kubernetes, a small Kubernetes cluster where you want to deploy your applications as containers, right? And almost all of the commercial thing, whether it's IBM, VMware, AWS, and GCP, everybody in their own when the platform that they are offering for the blockchain, they are all run on Kubernetes. Okay, so that's the quick summary and thing. If you are focusing on the real world implementation and work on the practical deployment of them, this is Kubernetes is the case, right? So I want to convey this message and take up the 30 minutes of my time to share my message. So this brings to the end of our session with both Swaroop and me. If you have any questions, please put it in the chat window. I will try to answer them. I know this is not an ideal session, especially just before the lunch. People will be waiting for me to stop. But it's slightly better than session after the lunch. but please, especially today, I would request you all to not to miss today's afternoon session because we have really good speakers, Sharayu and Pradeep, who both will be speaking on the mathematics behind these technologies, and it will be very interesting. I kindly request you all to not to miss out on those sessions. Okay, no matter how sleepy you feel after your lunch, please ensure that you attend that. So I do not want to eat into your lunch time. So this is my contact. You can feel free to contact me if you have any queries.